And I'm Evan. I'm here to talk about modern cloud infrastructure in Go with Pulumi. Thanks so much for having me tonight, Pacific Northwest. Really excited to be here. So I'm doing something a little different. I have some live polls that were set up ahead of time. So if you go to pollev.com/evanboyle164, you can vote in real time on these polls. So looks like a couple of people may have gotten a hold of my slides and beat me to the punch. So let's go for it. I want to hear, what's your background? Engineer, DevOps? Are you, a student? You just learning? Leave this here for a moment. All right, we have a developer-heavy audience tonight. Looks like we have some DevOps folks in the room tonight as well. Hi, good to see you. Awesome. Okay. Well, if you all keep this tab open, we're going to have a few more polls throughout the night. But I'm going to go ahead and move on for now. So what we're going to cover today: first, provisioning, treating your infrastructure as cattle, not pets. Second, architecture. These are things that we typically use in Go and other programming languages. Using abstraction and encapsulation where appropriate to share our best practices. Not repeating ourselves needlessly, but sharing those best practices across teams. And the third thing we're going to do is test. So look at unit and integration testing for our infrastructure, which is something that you would be surprised to hear is not entirely common. So if you want to get started, there are two things to do. So I pasted that link in the chat. If you want to follow along, Pulumi getting started for AWS, and then also cloning this repo, Pulumi examples, into your Go path. If you do that, you should be good to go. I'll just leave this here for just a second. I'm gonna have these steps up in another moment here. So another poll I want to hear: where are all of you in your cloud journey? Are you total cloud beginners? Are you just getting started? Maybe you're actually managing services in production. Excellent, healthy mix, but it looks like we have a lot of veterans here as well. Very cool. Well, hey, if you want to drop a note in the chat, I'm curious. For those of you managing services in production, I'd like to hear, how are you provisioning your infrastructure today? Okay, so you want to go to the cloud, get it? I got more where that comes from. How do you get there? Multifaceted, many different paths you can take. It's super confusing. You could create a VM in 7 easy steps using the AWS console, or perhaps the CLI, maybe the SDK, or you could write a CloudFormation template, or Terraform, or Chef, or Puppet, or Ansible. Wow, the choice is overwhelming. Yeah, seriously. So let's just take a step back for a moment, right? What do we want out of our cloud development process? We want maintainable and correct systems first and foremost. A familiar tool chain that we can use with the whole team, because software isn't built in isolation after all. We got to work with other people and whatnot, right? Confidence making changes, and then the ability to iterate in an isolated development environment, right? And I say, are these goals really different from traditional, desktop development? So yeah, why not rely on the same tool chain that we're used to using everywhere else? Good old Gopher. So now I'd like to start with a simple little demo. So what we're going to do here is create a security group with a public ingress on port 80, look up the latest Linux AMI. We're going to create an EC2 instance using those two properties that we defined. And then we're going to specify a very simple launch script that just starts up a server on port 80 and export that public DNS so it's accessible from outside of the deployment by other programs. I'm going to post instructions for how to get started, but I'm going to walk through this in my terminal real quick. Okay, so can I get a thumbs up, thumbs down? If this isn't readable, can someone who has audio access just chime in here? So what I'm going to do right now is clone the examples repo. This is Pulumi examples.
Hey, Evan, would you mind doing like one tick bigger than what you got?
How's that?
Cool, I think that should be good.
Okay, perfect. So I've cloned into the Pulumi examples repo here. And so now I'm going to cd into examples, AWS Go web server, okay? And first thing that we're going to need to do is initialize a new stack. This is kind of like a container for all of our resources, like a ephemeral developer environment, if you will. So PNW Go is what I'm going to call mine. All right, and then I'm going to set a little bit of configuration. I'm here on the West Coast in Seattle, so I'm going to set some config for the AWS region. And I want to deploy in US West 2. Oh. Pulumi config set AWS region. Perfect, okay. And then I'm going to run Pulumi up -- yes. And while this gets going, I'm going to go ahead and pull up these instructions real quick. And don't worry, we're going to look at the code here shortly. Okay, so this is the time to grab your computer, and here are the instructions for any of you who'd like to follow along at home. So go ahead and make sure you create that github.com/Pulumi path, cd into it, and then you're going to clone that examples repo, cd into the AWS Go web server directory, run Pulumi stack in it to create that ephemeral environment. And then we're going to set a config value for which region we'd like to deploy our resources into. It's US East 1, US West 2, whatever you want to do, and then run this command Pulumi up. So I'll leave this here for just a second for those of you following along. And you can see here that we have created a stack, which is that container that holds all of our resources. We've created a security group and an EC2 instance. And down here we have some outputs. So we have a public host name and a public IP. So let's go ahead and try and curl this, see what we get. Oh, great, we get a hello world. So let's go ahead and look at this code real quick. All right, so we have this pulumi.run. Mostly looks like any other main file that you would see, but we have this pulumi.run, which injects a context that we can use. It has some helpful utility functions, some Pulumi helpers, things like that. And first thing we're going to do is define the security group. And that security group just has an ingress that defines TCP traffic from port 80 to port 80 and defines a CIDR block. From there, we define our AMI. And we use this wildcard expression to look up what is the latest Amazon Linux AMI. Last thing we do, call ec2.newInstance to create our instance specifying the security group IDs that we found before and the AMI that we looked up before. And then here our very sophisticated web server. It's just a bash script that echoes hello world into an index HTML file and then runs a simple Python server. And you can see at the end here, this is where we exported those values that you saw in the output, the public IP address and the public host name, both that are outputs available on this server that we created. So another really cool thing about this is Pulumi has output commands, stack outputs that allow you to compose into other tools. So instead of just copying and pasting that value, we can do Pulumi stack output, and the value of that was public host name. Oh, a little bit of a typo there, but if I get that right, beautiful, hello world. Awesome, so let's break it down again. This is the set of Go bindings for the Pulumi core Pulumi project, and just this context function that gives us a container for which we can create cloud resources inside of. Here we import the AWS bindings, create our security group, redirecting traffic 8080, and create a CIDR block. Then we look up our AMI, use those two values, pass them into the EC2 instance, specify that user data, export those values so they're able to be accessed programmatically by other programs or by just us as operators using the CLI. And then finally, we can manipulate those outputs and see the response from our web server. Okay, I'm going to stop here real quick for any questions. I'm going to switch over to the chat. Let's see. You can't skate bash ever. Yeah, that's a great point. And actually, you can kind of escape it. We'll get to that a little bit later. Can you talk on how to maintain a remote state? Let's hold off on that one for okay. Questions tab. Let's see. Since Pulumi is all code using standard languages, is there a way to do TDD unit tests? So glad you asked. We're going to get to that later in the talk, but yes, there is absolutely a way to do test-driven development and unit tests. I'm going to defer the question on remote state. By remote state, do you mean how do you? Well, that's a little bit of a good segue into the next question. So I'm gonna defer that one for now. Okay, so this is perfect time for a pop quiz. Hope everyone's ready. Did you bring your pencils? All right, so if you can open up the chat again. Oh, looks like someone already came in here and voted, but is Pulumi imperative or is it a declarative desired state configuration? I'd like to hear what everyone thinks there. All right, a little bit of a mix, but it seems like okay. Well, I don't know. What's the answer going to be? Trick question. Why not both, right? So let's go ahead and look at this. If we run Pulumi stack export -- file stack.json. So and then let's go ahead and look at this output.json file. And let's look here. So what do we have? We have right here, this is our Go web server EC2 instance, okay? And inside of here, you can see we have inputs. So what are some of the inputs that we passed in? Here is that AMI ID that we looked up dynamically. Here's the instance size. There's all sorts of other properties, such as the user data. Here's our sophisticated web server. And you can see on the other side, we have all of these files that were eventually resolved. So what zone it's in, information about public, private IP addresses, etc. So going back to the question at hand here, you write imperative code, Pulumi executes it, produces a declarative state file that we already looked at, right? And drives to that desired state. So the answer to the pop quiz is Pulumi is both. It's both an interface for writing imperative code that's executed to produce desired state, and then the backend engine, which drives that desired state to completion. So I'm going to go ahead and switch back to the chat real quick and see, do we have any questions here? I do agree. It's imperative that you eat more fruit to stay healthy. Yes, thank you very much. Right. If there aren't any other questions, please feel free to drop them in the chat if you have them. I'm going to go ahead and move on. All right, so Pulumi allows you to create reproducible, isolated instances of your project. We call these stacks. So each developer can spin up and tear down environments as will. If your environment gets forked, you can just take it out behind the shed and put it to rest and spin up a new one. So that life cycle here looks like Pulumi stack init to create a new environment, Pulumi up to populate it with cloud resources according to the state that you've defined, Pulumi destroy, which cleans up all of your resources because we don't want to pay for that, right? And then Pulumi stack RM to delete that container and delete the history associated with it. So we're going to go through just a very small amount of Pulumi 101 here real quick. You may notice that we redefined some types here. We had that strange Pulumi.int and Pulumi.string for, for port 80 and for TCP. Like, why? Why would we do this? Why? Well, deploying to the cloud is fundamentally asynchronous, right? Some values we know at runtime, like we're building a web server, we always want to expose port 80, but others only resolve at runtime. Like, what is that public IP address of our EC2 instance? If you know that ahead of time, I may have a business proposition for you. But so Pulumi has what's called inputs and outputs. So talk very lightly about types here. So if we just consider T to be some type, so T could be a string, T could be an int, it could be an array, it could be a complex struct. An output is an asynchronous object that promises to resolve with a value of type T. So if you've ever used JavaScript before, this is very similar to promises. So we create that EC2 instance and every member of the result. So you may remember we looked at that state file. So everything here in the outputs, this AMI, this ARN, all of these are asynchronous values that promise to eventually resolve, but are not immediately available when that code runs. So an input of T is either an output of T, so is either that eventual value or a promptly available concrete instance of that type. So this could be, an async value, that security group ID that doesn't exist yet, or it could be that port that we've already defined, port 80. So when creating cloud resources, all these input arguments must be input of T to accommodate both prompt and async values. So everything feeding into a resource when you create it in Pulumi is an input, and everything that comes out is an output. And so, why all these custom types? Everything comes back full circle, right? This goes back to our lovely generic questions that we talked about at the beginning of the meetup tonight. So Pulumi uses union types in other languages to represent this. So an input is either a T or an output of T. And Go doesn't have generics for now, at least. So we must define our own custom types. And those custom types use a combination of strong typing, interface, and then reflection under the hood for runtime checking to allow us to represent this union type, this generic union type, while still offering that strongly typed API. So it's a little strange, something to wrap your head around, but is what it is. Let's see if there's any questions on that. Oh yeah, static IP. All right, that's your business proposition for me. I may be out of a sum of money. I spoke too soon. All right. Any other questions? Okay, looks like a few have popped up in the meantime. How's your feature parity with the likes of Terraform and CloudFormation? How long does it take between new services launched and Pulumi can support it? So Pulumi actually uses some of the Terraform providers under the hood. So we use the Terraform AWS provider, for instance. So those are up to date just as fast as the AWS providers are, or the Terraform providers are. We don't actually, just to be clear, we don't actually produce Terraform or anything like that. We just use we are compatible with some of the underlying provider mechanisms. And for others, like we have some native providers that we've written ourselves, like we have a fully modeled the Kubernetes open API spec. So we code generate a bunch of SDKs based off of the Kubernetes open API spec. So when 0.18 came out 2 weeks ago, we actually had our support launched before the PR was merged for Kubernetes 0.18. So very, very fast because a lot of this stuff is fully automated. Let's see. Try to stack RM, but forget to destroy. Would you be able to delete the stuff you created? You can't, unless you do a forced deletion, you can't delete a stack that still has resources inside of it. So you will be warned. Okay, so where is history for Stack stored? This is another good one. So by default, state is managed in the Pulumi SaaS, which is free for like open source and individuals. There are like obviously paid plans for like enterprises and whatnot, but there's a S3 state backend, there's GCP, there's local file backend. So you can manage that state yourself or in a variety of cloud providers, or you can manage it in the Pulumi SaaS and see that full history. You do not need to use Pulumi.com to be able to use Pulumi. Okay. Let's see. In case of collaboration with multi-dev, how to maintain remote states. So yeah, this is where something like we have a SaaS or we have like an on-prem hosted state management solution that you can use. And if you're talking about like collaboration with multiple developers, you're talking about locking and concurrent updates and things like that. It handles all that stuff. Very cool. Okay, I'm going to go ahead and continue on. Manipulating outputs. Okay, so we write these programs. We have these values that can either be promptly available or asynchronous. Like you can't just add two promises together or concatenate two promises. Like it just doesn't work like that. Anyone who's done this async programming knows. So we have to have some way to be able to manipulate these values. Normally we just use sprintf. We just add this thing together. We just set that value of the struct. It's not that straightforward when you're dealing with the cloud. This fundamentally asynchronous programming. So we have what's called apply, which allows us to specify a callback function that manipulates the underlying value when it becomes eventually available. And that's going to return a new output, and that new output can be propagated into other cloud resources that you may want to create. For instance, you could take a bunch of URL components, and when they're all available, maybe the server, the protocol, the port that gets assigned, maybe some network information that's determined at runtime. You can apply all of these values together and then return a URL that can be used as an input into another cloud resource that you're creating. So this looks like this. So we have our VPC and we want to take that output property, that DNS name. We know it's not available right now, but we know it'll be eventually available. So we can attach this apply string callback on there that waits for that value to be eventually available and then splats on an HTTPS at the beginning. And then now we have this URL value, which is now a new output, a new eventually available value. So what if we want to do that coordination that I talked about earlier, like waiting for maybe a database and a SQL server or something like that, and then creating a connection string. So we can use Pulumi.all, very similar to promise.all if you're familiar with JavaScript promises, to await these two values, so the SQL server and the database, wait for those two name values to be available, and then we call apply over an array of those values, do a little bit of string manipulation, and then return them back. And once again, connection string is a new asynchronous value. It is an output, and that output can be used to pass into other cloud resources. All right, and we have, since this is Go, we try to, when we're building this SDK, we try to be idiomatic and, try to do what we can to smooth over some of these idiosyncrasies. So we do have a Pulumi.sprintf, which basically under the hood combines apply and all in order to use something like you would be used to with normal sprintf. But URL, once again, is an asynchronous value, so something to be aware of. Any questions here? Let's go ahead and take a look at the chat. Yeah, Pulumi's tools are open source. That is not something that I mentioned, but yeah, something to definitely be aware of. Pulumi's open source completely. You can go and look at the Pulumi providers, all of our cloud providers and SDKs. All the work that I do is open source, which is amazing. Let's go ahead and look and see if there are any new questions. Pulumi do auto deploys. If you push to master, will it automatically do a deploy for you? So yeah, we are not a CI/CD operator. Like there's lots of CI/CD providers in the space, and we integrate with most all of them. So we have like orbs for Circle CI that are pre-built that you can just grab and go if you want. Let's see. Are you able to talk about how folks are currently using Pulumi? Oh man, that is a super long conversation. Everything from people building SaaS, people migrating 50,000 line Terraform legacy deployments that they have into something that's more componentized, more manageable. We have people who are doing lots of Kubernetes, lots of serverless workloads. We call ourselves modern infrastructure as code because we have put a great deal of emphasis on support for things like Lambda, building Docker images as a part of your deployment, pushing those up to registries. We have a Docker package that will actually build your app for you. You can specify like build parameters, so you can build your Docker image and then deploy it to ECS. A lot of Kubernetes stuff. A lot of people who are doing both the deployment of their underlying like infrastructure, like defining VPCs, deploying EKS clusters or GKE clusters, and then also in the same program defining their Kubernetes resources, which is really, really cool. All right. So architecture as code, we want to compose our infrastructure into useful units, extract these into functions, publish libraries, share these with the team. And we acknowledge that when doing something like a VPC configuration, not all of us are Sean with extensive experience doing RTC and extensive network understanding. Like maybe you want to abstract some of that stuff away from your team for security purposes. You have best practices you want to follow. So let's take a look at our example that we wrote previously. So we've pulled this all into a create infrastructure function that returns this infrastructure struct that just has the raw group and the server exposed, right? But all of the logic is now hidden and nothing's configurable anymore. One thing to note down here is that in that AMI, we're now using a hard-coded custom AMI. So we have this AMI value for the new EC2 instance, and we're not specifying user data anymore. So our Hello World web server is no longer using that user data. It's no longer configurable. It's the stamped and approved image produced by our company, right? And so the main code here looks very similar. It's just a lot shorter. We run that create infrastructure function, and then we export the public IP and the host name just like before, right? But it's a simpler interface for maybe those who want to run a web server but don't want to be exposed to all the details of network configuration and which AMI to pick, yada, yada. And so these improvements are shared, right? Like I said, we don't have to worry about the network configuration. We can encapsulate and expose the appropriate level of detail. We can enforce policy, like make sure that everyone has the appropriate tags on all of our deployments that allows us to build like operational tooling, further automation. Stop real quickly for questions here, just in case. Let's see. I agree that it is super cool that you can define K8 stuff right next to other stuff. Yep, and we see a lot of people who do things like K8s for their compute and stateless workloads, but they take advantage of like data solutions in AWS and Azure. So maybe they have SQL in Aurora, or they want to do some log analytics in GCP, some machine learning in GCP. It makes it really easy to do that. How do you handle the version of the Pulumi API? So we release minor versions every week or so, and we try very hard to maintain semantic versioning. Basically, that's what we try to follow. So we are actually about to next week go from 1.0 to 2.0, which is really, really exciting. So there are a few minor breaking changes. Nothing for Go that's going to be a break, because Go is actually going into preview, or going out of preview and into GA. So you'll get a full contract, which is really exciting. All right. So testing, yeah, finally getting to the stuff that everyone's excited about, right? Love writing tests. So, since we're in the ecosystem, can we use Go test? Can we use, our favorite mocking tools, Go cover, like all the tools that already exist? We don't need to reinvent the wheel, right? Can we do this? Hopefully, maybe. Yes, of course we can do this, right? It's one of the big benefits of using a real programming language is that you can take advantage of everything that exists in that ecosystem. And so let's go ahead and write a unit test against our create infrastructure function, right? So we want to verify that that service has that tag, so we can build that operational tooling, right? That No one is specifying that user data. We pretty sure that they can't because we wrote that function signature that takes in no parameters. But we want to just be extra super careful. And then we want to check that SSH is disabled because it'd be really bad for someone to be able to log onto a server and take our user data. So this is another good time to go ahead and grab your computer. I'm going to switch over to the terminal and I will post instructions in just a second. All right, I'm going to go ahead and do a Pulumi stack destroy -- yes. Or sorry, not Pulumi, Pulumi destroy -- yes. All right. And while that runs in the background, this is just to clean up my old AWS Go web server resources. I don't want to pay for those. So I'm going to open up a new tab and I'm going to cd back into testing unit Go. Okay. And we can go ahead and open this up and look at our main. This is our create infrastructure function that we had, right? And then look at our main test. We have some mocks that are not super exciting. And then we're going to step through this testing code here. It runs inside of a standard Pulumi run. This variant returns an error so that we can check and make sure. And essentially, we're going to use pulumi.all and apply to await for these asynchronous values that we've mocked out. And then inside of those apply callbacks, we're going to do some assertions and use wait groups to coordinate everything. So we have a wait group of 3, and then we're running 3 assertions. And we, looks very much so like a standard unit test. Test infrastructure takes in a star testing T, and then we can run that test from here. But I'm just going to go ahead and go back to my console and just run go test. And so while that gets started, I'm going to put those instructions up for anyone who wants to do this. So yeah, Pulumi examples, testing unit Go. And then all you got to do, go test. And you can deploy this example if you like. It may require you setting some additional configuration, but yeah, it's there. You can check it out and try it if you want. Okay, cool. And you can see, hey, half a second and our unit test is executed. So let's dive in a little bit and see. We got a passing unit test. That's awesome. Let's check out what does this thing actually do. That's why we're here, right? All right, so like I said, we have this Pulumi.run error. This one's a little different because we specify some mocks as an additional parameter, so Pulumi.with_mocks, and pass in those mocks that we defined above. And we're using a wait group to coordinate these 3 sort of asynchronous tests that we're going to run. And so our first test, we want to test if this service has tags, right? So we're passing in that server URN, that unique address that we can use to identify it. Then we're passing in the tags from that server. Just passing in the URN here so that we can add a little bit of verbose logging if perhaps something fails and we have a bunch of resources in our stack. So wait for those available values to become available. Call this apply callback. And then make sure that that name tag exists inside of the tags collection that gets passed in. And you do see here that because of the nature of like generics in Go, when we do this all that gets called into this apply T, we do have to deal with interface. This is a result of providing something that is, works with these union of input types, this T and then output of T. In a language like Go that does not support generics. And it sounds like many of you hope it will never support generics. So. And then we have this other test that just tests to make sure that user data is empty, basically. So want to make sure that that user data value is nil, that no one's clobbering that AMI that we worked so hard to pre-build with our blessed web server image on it, right? And then this one's a little bit more involved, but similarly passing in that URN and that ingress and awaiting those values. Then once they become available, we're going to loop through everything in the ingress that we have and just have a little flag value to see if something's open in the internet. And if we're on that open CIDR block, we're going to break out and fail. But this shouldn't look too foreign. This is very, other than the all and the apply, this is probably very similar to unit tests that you're used to writing inside of Go. So these are unit tests. We aren't verifying the functionality of a particular cloud service or the behavior of your infrastructure. You can't make HTTP queries to cloud resources that don't exist. They're mocked out. these tests are only as good as the mocks that you write. But you can verify quite easily things like control flow, logic, propagation of expected values, and configuration. This behavior of your code in isolation of the crowd. So if I call this method, how many Lambda functions are going to be created, or how many EC2 instances are going to be created. And as you said, half a second. This is blazing fast. Doesn't require that CLI binary to be on your machine. And it gives you that sort of tight inter-dev feedback loop that a lot of people really love. I love it. Any questions here? Let's go ahead and stop for a second. All right. Is there a way to make your tests actually try to destroy my infrastructure? Oh, wow. It's so great when people throw you a softball that you're set up to answer in the next slide. How do you handle the version of Pulumi? Okay, we got that. Thanks, Aaron. Yeah. He says he'll take his payment via Venmo. All right. I'm going to go ahead and move on since, Aaron needs to get paid, obviously. Integration testing. Yep, you are right. So we do have ways to do full end-to-end verification of our deployments, spin up our cloud resources in an ephemeral environment, execute some code afterwards that has access to those stack outputs, that has access to those cloud resources, and then tear everything down. Make sure we don't leak those resources in CI or in your local development environment, because we don't want to continue paying for that, right? Cloud is expensive enough as it is. So this is how we can verify the integration of cloud resources. Like when I change that IAM role, did I suddenly lose access somewhere? Did I tighten things down in the proper way? Verify that EDE requests can flow through the system. And then, yeah. So let's go ahead and I'm not actually going to do a code demo for this one because, as we said, deploying cloud resources, spinning them up, executing, waiting, doing retries, and then tearing down the resources doesn't demo quite as well. But this is inside there. I will just go ahead and show you where this code is. So testing-integration. And if you look inside of here, one of the things that's kind of cool, if we do ls program, we're actually using our Go test harness to deploy a TypeScript program here. I hope that I get invited back after showing TypeScript during the Go meetup, but we're actually not going to talk about the TypeScript program at all. Just think it's kind of cool that our test harness does support executing languages in a variety of other, or executing programs in a variety of other languages through Go. We at Pulumi are Go engineers. The whole Pulumi engine, CLI, all the providers, everything is written in Go. It is our favorite language, and something I'm excited to work in every day. But yeah, long story short, if you want to follow along and try this out later, you can go to the testing integration. Cool. So here we have some basic configuration that's defined. Once again, just looks like a regular Go test, right? Takes in a testing object. And so we have this program test options that specifies where do those files that you want me to do the Pulumi up over, where does that program live on disk? Some other configuration values. And then you remember how we had to specify what region we wanted to deploy our resources to. So you can specify that same config map programmatically through this test harness. And then this extra runtime validation function is what gets executed after your update has completed successfully. So in this case, we're going to look for our stack outputs for our website URL, that public host name that's exposed. And we're going to execute that request with a little wrapper that does some retries. And just once we get that result body, we're going to assert that it has hello Pulumi, which is what we had baked into our web server. Awesome. So, integration testing, this is how we validate the end-to-end flow of our cloud resources in the wild. This is a much slower process than unit tests. It does provision that full replica of your infrastructure, but it really brings confidence and enables CI/CD for infrastructure and moving really quickly. You can't always test every edge case, and every new developers aren't always aware of all the nuances when starting to poke at infrastructure. So this is what helps you hit that green button, merge your PR, and let it get deployed through your CI/CD system and not have to look back. But yeah, what do we test here? We test, we can do really interesting things like test health checks and alarm configurations. Mentioned before, IAM bugs and things like that. My favorite is the ability to actually simulate deployments, right? So if you have like a secondary environment, you want to do a simulation of updating the stack from one state to the next, you can actually specify multiple steps. So you could specify like different Git hashes of the same Pulumi program. So you could deploy the old program first, and then apply an extra step and edit that now does an update. And so you can do things like simulate that prod deployment and measure uptime, like see if you're going to cause a database outage. That's kind of cool. And then finally, this is the ecosystem. So today, Pulumi, all of us Gophers here, we're not really interested in this, but if you did happen to be, we do support TypeScript, Node.js, Python, and then all the .NET languages, integrations with all the source code providers. You can use whatever tools you're using today. So, NPM for JavaScript, you can use VS Code, all the Go plugins that are available there. We have CI/CD integrations, and then available on all the cloud providers. So AWS, Azure, GCP. Like I talked about, we have full modeling of all the Kubernetes resources. We actually have this really cool capability. It's not quite finished yet in Go, but in other languages, you can use our APIs to generate YAML. So if you have some sort of bespoke Kubernetes deployment process and you hate writing YAML, you can write in your language of choice and produce that Kubernetes YAML using strongly typed APIs and this declarative sort of desired state model. Yeah. So just in review, we talked about provisioning. So how do we automate our team setup? How do we automate our application development environments? Treat everything as cattle, not pets. Make sure that we're not incurring too much cost. Automatically clean things up. And then how do we apply architectural best practices, right? Things that we're typically used to in Go, right? Applying that right level of encapsulation for the consumer that we're authoring for. And then last, how do we apply testing best practices, both fast interdev loop unit tests and full confidence integration tests that let you move quickly, yeah. And really appreciate everyone taking the time tonight. Really enjoyed being here and talking to you and all of the witty comments. You all are quite a funny group. Lots of ways here for you to learn more about Pulumi. You can hit me up directly on Twitter. Feel free to drop into the Pulumi Slack. I'm Evan on the Pulumi Slack. Would love to hear more from you. If anyone wants to get started on some feature requests, we have a list of issues that are good getting started in Pulumi. So always looking for new contributors and help from the community.